Welcome to the Sidecar Sync podcast, your home for all things innovation, artificial intelligence, and associations. Greetings, everybody, and welcome to the Sidecar Sync, your home for all of the content you can possibly imagine at the intersection of artificial intelligence and the world of associations. My name is Amith Nagarajan.
And my name is Mallory Mejias.
And we are your hosts. And we're up to no good once again over here at Sidecar, right, Mallory? We're working on the next edition of Ascend. And you are taking a deep dive this week and kind of reviewing what's changed in the last 12 months since we last updated the book. What's going on so far with that?
You know, I am just working away on Ascend 3rd edition. Super exciting and a really great exercise to be able to look back on the past year or so and also look ahead for kind of what's coming or what we think might be coming in the next 1 to 2 years. I will say going in, you and I both talked about how, we don't know if that much of the book will have changed from 2nd edition to 3rd edition. I can tell you, Amith, I think a lot is going to have changed. We're going to be talking about advanced reasoning models. We're going to be talking about MCP, which we've talked about on the podcast. Right now, I'm kind of outlining our section on AI-generated video, which we did mention briefly in the last edition, but there's just been so much progress since then. Even with something as simple, quote unquote, as image generation, right? We had ChatGPT's native image ability that can get words correctly. So I want to stuff as much as I can into the book, but I'm trying to keep it simple, digestible. So it's been a really fun exercise to look back at the past year and see what's changed for associations specifically.
Makes a lot of sense. And, the retrospective that we go through and making a major update to Ascend. And for those of you not familiar with it, it is our totally free digital download and print book available that is specifically written for you in the association market. And it is all about how to think about AI, obviously teaches you a lot about AI, and also tells you a lot about how to think about adopting AI in your organization. And, certain aspects of that book, I think, will probably stand the test of time. But we wrote that book in its first incarnation in 2023. Around March, April is when we first released that and or first started really working on it in depth, and we released it, I think, in June. And then we updated it again, a major update, basically a rewrite around this time in 2024. And here we go again. And on the one hand, some of the concepts we talk about there do stand the test of time in terms of the general thought process around how to think about AI, how to create flexibility, how to create clarity, how to improve your culture, how to bring everybody along, how to think from a bottom-up perspective, not just a top-down perspective, meaning really inculcate into your team a sense of wonder, discovery, curiosity, give them tools, and set clear guidelines so that you can have as much bottom-up innovation as you can possibly imagine, well beyond what you can do top-down. Those concepts, I think, will be relevant in 5 years and maybe in 50 years. But, a lot of what we talk about in the book is how to think about prompting and how to think about agent design. And to Mallory's point, video, and that's changing so crazy fast. So, every week we do this and we talk about what's up right here, right now. And this is an opportunity to look back 12 months or so and make a major update. So really exciting stuff. We can't wait to bring that to you. If you needed another good reason to come to digitalNow 2025, which is in Chicago, November 2nd through 5th, you have yet another one, which is that we are committed to producing this new edition, the 3rd edition of Ascend, prior to that show. And if you are in person, you will receive a copy of the book at the event. Plus, it's at a pretty cool venue, the Woes, downtown, very close to the river, very close to the lake, really cool, brand new hotel. So can't encourage you enough to be at digitalNow November 2nd through 5th. So Mallory, what do we have going on today?
We've got a lot going on today, Amith. Aside from the podcast, I've got 2 doggos behind me playing. So if you guys hear any growling, I promise all is well on my end. But we're going to do something a little bit different today, and I'll be curious to hear what you all think about it. So I want to start with a rapid fire segment on 3 quick AI updates, and then we'll dive into a more critical issue that could fundamentally change AI's trajectory. First, rapid fire, we're going to be talking about Claude versus ChatGPT voice modes. We'll be talking about Google's tiny but mighty Gemma 3 model and some of the backlash and reception around GPT-5, which we just covered. Then we're going to be talking about how AI's massive energy consumption is driving a revolution in computing that mimics the human brain. So, first, we've got Claude versus ChatGPT voice. You all know we've been huge fans of ChatGPT's voice mode for a long time, especially Amith. You use it constantly on walks, on drives, basically everywhere. When Claude Voice launched back in May, it had kind of, this walkie talkie style where you press a button between turns. It didn't seem compelling enough to leave ChatGPT's seamless flow, but Amith, recently you posted on LinkedIn that you're finally switching to Claude Voice after you had some GPT-5 connection issues. So can you talk a little bit about that?
Yeah, I have mixed emotions about it, to be honest. I switched to it simply because GPT-5 has been super buggy for me, just in pretty much in all aspects. API usage, using it in the app, using voice mode is basically not functional. And I sure hope OpenAI fixes this stuff up. I mean, they probably just have an insane amount of demand, and I am empathetic to that. But at the same time, they're the big player in the space. They need to do better than this, and I know that they're working on it. But my viewpoint is that sometimes this happens because you're kind of forced to. So I was all excited. I was going for a walk the other evening, and I was all excited. I was going to talk to my AI buddy ChatGPT all about some ideas that I had, and I do this a lot for brainstorming. And so I get on ChatGPT and I try to connect, and I try to connect, and I try to connect. That didn't work. So, long story short, I even tried the 4.0 model to try to downgrade myself and see if that would work. Didn't work as well. In any event, I said, well, I know Claude and I love Claude for using on the desktop. I use it for software development. I use it for writing. I use it for a lot of things. And that's my go-to on the computer and in general. In any event, I went to Claude because I knew they had this capability, and I had an incredible experience. That's what I wrote about on LinkedIn actually shortly after I got home from my walk because, I was just kind of in my mode of using ChatGPT because I got used to it, just like we all do. And using Claude that evening really made me rethink what I'm going to do. And I didn't quite mind the walkie-talkie nature of it, the pressing the button. I kind of got used to that pretty quickly. In fact, in a way, it reduced a little bit of anxiety that I sometimes have with ChatGPT voice, where you kind of feel like you're going to get interrupted. And I'm a little bit long-winded, as our listeners know. So it's one of those things that ChatGPT tends to interrupt me. And therefore, I kind of like Claude only talking when I ask it to.
That is so funny. I can imagine you just going on this long, intelligent rant and then voice mode being like, oh, and you going the back and forth thing like on the podcast. I tried out Claude Voice as well. I thought the walkie talkie having to press the button every time you talk, it is a little bit clunky in my opinion. I kept forgetting, but once you get the hang of it, it's not so bad. I felt like the audio quality was also a little less impressive in Claude Voice than ChatGPT. But I actually want to skip around then. I was going to talk about Google's Gemma model next, but since we're talking about GPT-5, I want to discuss briefly how the rollout has been messy. You just mentioned how it's been buggy for you, the same for me. Users are also saying it feels cold and clinical compared to GPT-4o's warmth. Some people joking, I don't know if it's completely a joke, that they lost their friend overnight when OpenAI yanked the older models without warning. We've also discussed the model router system that picks up different variants for different queries, which users don't like, or some of them don't like, because they don't know what they're getting. Sam Altman has also admitted that they kind of botched the launch and brought GPT-4o back as a legacy option for paid users after that backlash. So, Amit, talking about GPT-5 here, what is the lesson? What is the takeaway for associations with this perhaps botched launch?
Well, I think one of the lessons is you need to move pretty quickly in order to innovate and try new things. And sometimes you're going to get it wrong. So I think being open minded about that as an organization and being willing to take some risks, you don't get a home run if you never swing hard. So you have to go for it sometimes. And clearly that's what they've done. GPT-5 is a big release. It has lots of different things to it. I think it's an exciting step forward for the industry. I think they're going to figure it out over the next 30 to 60 days, probably. And then it'll be quickly, I don't know about quickly forgotten as what I was going to say, but it'll be an element of their learning as an organization and probably the industry's collective learning. But they're at a scale that nobody else is at by an order of magnitude, right? They have 700 million weekly active users. They'll probably be at 1 billion weekly active users by the end of the year by most projections. That's a different problem domain than Claude or anybody else in this space has right now. So again, that's why I'm empathetic towards it. But I think one of the things to learn is solving multiple different problems in parallel. So what they're trying to do is make the model smarter with GPT-5's thinking mode, with all the capabilities they touted in their live stream a couple weeks ago. At the same time, they introduced GPT-5 Nano, and I believe one of the reasons users are having the problem they're having is many things users ask for are not very complex. So it's not necessarily a sophisticated, complex reasoning problem, but when you get routed to the smallest possible model, which is what's happening, I think, a lot of the time, the responses, the quality isn't quite as good. It's probably actually a step back from GPT 4.0 in terms of personality, tone, style, warmth, etc. Whereas the full GPT-5 model is probably an order of magnitude better than 4.0. I really don't know, honestly, because I haven't been able to test it that much due to the issues I mentioned.
And that I will point out to our audience is a lesson in friction. You've got Amith here, avid GPT voice mode user who is experiencing some bugs, a lot of friction using the product, and is now using Claude Voice. Do you think you'll go back to it, or do you feel
Yeah,
like
I was
you're
gonna
all in on
say
Claude?
I'm not like a done forever kind of person. You
Okay.
know, I'll kind of let myself get burned quite a few times by something before I learn. So it's partly because I want to, give people multiple shots. I appreciate that being on the other side of the fence as a vendor. When you mess something up, people giving you some grace to quickly fix it as long as you're super transparent about it and you're on top of it. I think that makes sense. We're all human. Even the AI is kind of human at times, right? So we all mess up. So I don't think this is in any way going to be a long term negative for OpenAI. I just think that it's something that they need to get past. They need to quickly address this. Probably need to go out and like suck up the entirety of the compute supply that's coming online and available, and of course everyone's competing for that as well. So it's an interesting time. I think the only other thing I'd say is expectation settings. So when they rolled out GPT-5, obviously they had a bunch of test groups, small numbers of people, but they might have considered like a larger beta with maybe, you know, I don't know, a fifth of, or sorry, not a fifth, 5 times as many people or 10 times as many people as they had in their early testing. Because I think they would have learned a lot of these things if they open it up. Part of the problem with the early testing group they had is it's people like Professor Ethan Mollick, who we talk about from time to time, and a variety of other obviously very knowledgeable power user type people. And their patterns of use are going to be different than the average end user consumer. I think that they could have done well by opening up testing a little bit more broadly. That's an old school playbook from the software industry. I mean, software companies oftentimes would have beta periods that were even public betas where people could just opt in, or closed betas where you have to be invited. But either way, a lot of people would know about the beta for a period of time. Part of course, the pressure in this world is things are moving so incredibly fast and so competitive that I think a company like OpenAI or Anthropic or others is probably hesitant to do something that open. But I kind of sense that some of that will start happening in the future because of this.
I also, doing some prep for this topic, I read that Sam Altman said they have better models. They just truly can't release them because they don't have the infrastructure, the compute to support it, which I think is really interesting and kind of ties into our main topic of the day. But before we jump into that, I want to talk about how Google just released Gemma 3, an open model with a 270 million parameter variant. That's million with an M, making it one of the smallest language models available. Most small models these days that we cover particularly have a B in their name to represent billions of parameters. The latest OpenAI models we covered, OSS 120B and 20B, are an example. But this tiny thing can run directly on phones and browsers and supports 140 languages. Amith, what is your takeaway on the latest Google Open model? It's a trend line we're understanding, we're seeing all the time. What's your takeaway?
I think what you just said is the key part, the trend line. And so what we're seeing is model compression. We've been talking about this for the entire time we've been doing the Sidecar Sync, almost 2 years now. And the essence of this is that we have the compression of knowledge and ultimately intelligence into smaller and smaller form factors. And as you make something smaller, it's cheaper, it's more portable, it's faster as well. So Gemma 3, 270 million parameter variant will run, roughly an order of magnitude faster than a 2 billion parameter model and roughly 2 orders of magnitude faster or 100x faster than a 20 billion parameter model like OSS 120. And that's all else equal. Architectures may differ. Many of the larger models that say, hey, we're, 500 billion parameters are MOE models or mixture of expert models, which is a fancy way of saying they actually have multiple different models built in and they automatically switch, which by the way is different than GPT-5's router. Those are actually totally separate models, and there's a piece of software on top making a choice at first. Whereas the mixture of experts have a router concept in them, but it's on a per token basis essentially, and it's nearly instant. Very, very different idea. In any event, getting back to the question, if you can get 140 languages and a good bit of the knowledge of humanity into a little model like that you can put on, the smallest possible thumb drive, you could probably run it on an Apple Watch. That's unbelievable. It just tells you how far we've come, because this model is, I don't know what the benchmarks are saying because I haven't studied this one, but I'm guessing it's probably something like a GPT 3.5 class model, maybe even a GPT 4 Turbo, the original, scale GPT 4. That model, it's probably comparable because that model is a year and a half old. So if this little tiny model is about as good as state of the art AI from 18, 24 months ago, that's a pretty amazing feat. And when you put together lots and lots of inquiries to small models, you can do some pretty amazing things. So I'll give you an example from the world that I've been spending a lot of my time on for months now, which is this Skip AI agent that we've talked about on the pod a number of times. Skip is essentially an expert at data analysis, programming, and talking to users. It's a conversational agent that can go throughout your enterprise-wide data catalog, extract data, transform it, and ultimately write code to present it to you in the form of interactive charts, graphs, dashboards, things like that. Essentially, it's an analytics solution. It's very conversational, like ChatGPT or Claude, but it lives in a secure platform. Now, this agent, what it does is it actually breaks down a problem into dozens, sometimes hundreds of small problems. So if you need to, for example, build a membership dashboard, there might be 20 or 30 different components in the dashboard. So Skip doesn't just do it all at once. Skip will break it down, analyze the problem like a human would or like a team of people would, and then ultimately breaks it down into lots of different component parts, and then is able to spin up lots of instances of small models, which will generate first drafts of all of the different bits of code that are needed. Then use slightly larger models to test that, slightly larger models from there to compose it, ultimately resulting in potentially hundreds of prompts being run. You can't do that if you need to use the biggest possible model. If you have these small models that are they're not as smart, but they're really smart models, you can do amazing things. You just have to think creatively about it. So the trend line, getting back to your point, is the key message. It means that AI is getting cheaper and cheaper, approaching free, and the intelligence level keeps going up. Another way to put it is if you can get 90% of the power or 80% of the power of something truly revolutionary, or pretty close to free, and it's very fast, versus 100% of the power for very, very high prices and it's very slow or hard to get access to, most people are going to pick the 80, 90% solution because it's amazing. It's not like an airplane ride where you want to say, hey, do I want 80 or 90% of the airplane ride? No. I really want 100% of the airplane ride. I want to land.
I want a
This is,
frontier
yeah,
airplane ride.
yeah, exactly. So I want the best airplane. In this case, it's a totally different type of thing to analyze this on. These small models have unbelievable utility.
At Sidecar, we know the power of bringing the brightest, most innovative minds out there together in person to learn and grow. And that's exactly what we do at our annual conference, digitalNow. digitalNow is a 2.5-day conference bringing Silicon Valley and executive-level content to the association space. We bring in expert speakers from places like Google, Amazon, and the U.S. Department of State to share insights on emerging technologies and how they're reshaping the future of associations. Whether you come solo or bring your team to collaborate and implement together, you'll leave with a clear vision for what's next. Join us November 2nd through 5th, 2025 at the Lowe's Hotel in Chicago. To secure your spot, visit digitalnow.sidecar.ai.
Is your association drowning in disconnected systems and manual processes? Symmetry makes IT less scary, including AI. We're the only firm offering secure, vendor-agnostic AI specifically for associations. Early adopters are already seeing dramatic results. AI implementations can reduce manual tasks by up to 80% and free up over 20 hours per staff member weekly. From managed IT services to revolutionary agentic AI deployment, we transform how associations operate. Ready to lead your industry's AI transformation? Visit Symmetry.com for your free AI readiness assessment. Symmetry, AI strategy and agent deployment for associations. That's Symmetry.com, CIMATRI.com.
If you're listening to this podcast right now, you're already thinking differently about AI than many of your peers. Don't you wish there was a way to showcase your commitment to innovation and learning? The Association AI Professional, or AAiP certification, is exactly that. The AAiP certification is awarded to those who have achieved outstanding theoretical and practical AI knowledge as it pertains to associations. Earning your AAiP certification proves that you're at the forefront of AI in your organization and in the greater association space, giving you a competitive edge in an increasingly AI-driven job market. Join the growing group of professionals who've earned their AAiP certification and secure your professional future by heading to learn.sidecar.ai. All right, let's move to our main topic for today, AI's energy crisis and the neuromorphic solution. So by 2027, AI is projected to consume 100 trillion watt hours of electricity annually. That is as much as the entire country of Argentina. We're also talking about 200 billion gallons of water per year just for cooling data centers. Tech companies are literally considering nuclear reactors to power future AI infrastructure. The root cause is something called the von Neumann bottleneck. The problem isn't actually AI itself, it's how computers have been built since the 40s. The von Neumann architecture separates memory and processing units, and moving massive amounts of data between these two consumes enormous power, especially with today's data-heavy AI workloads. Claude came up with this analogy for you all. Think of it like having your membership database in one building and your engagement tools in another city. All that shuttling back and forth wastes massive energy. Here's something that really puts this in perspective. Back in 1997, IBM's Deep Blue became the first supercomputer to beat a world chess champion, Garry Kasparov, one of the greatest chess players in history. But here's the energy comparison that will blow your mind. Kasparov could play that championship-level chess using the energy equivalent of a single hot dog. Deep Blue, the supercomputer, needed the equivalent of 250,000 hot dogs worth of energy for the same game. The human brain operates on about 20 watts, less than a light bulb, while AI supercomputers need megawatts. The brain's secret, not so secret, is that it co-locates memory and processing, no shuttling the data back and forth. Everything happens in the same place, dynamically and efficiently. So scientists are now developing neuromorphic computing, chips that mimic brain architecture where memory and processing occur in the same place. Using nanotechnology, these devices can be reconfigured with electric fields, just like neurons and synapses adapt in our brains. Mark Hersom is the chair of materials science and engineering at Northwestern, and his lab has already demonstrated nanoelectronic devices capable of machine learning with 100 times less power than traditional computers. The topic today, too, I should mention, was inspired by Mark Hersom's TED Talk that we will link in the show notes. Amith, kind of just an observation on this point before we get into questions. I think it's so fascinating that technology is mirroring biology, and that when we don't have a solution to a problem, we can kind of look at the human body or look at nature, for example. And I did a little research on this with Claude just because I was going into kind of a nerdy deep dive. But obviously, we have neural networks. So basically, the entire AI field copies how brain neurons connect and fire. I didn't know this, but Microsoft is looking at storing data in synthetic DNA, which is nuts. The Amazon warehouse routing mimics how ants find food. Anyway, those are just a couple examples I wanted to share with you all. I think it's really neat to think about how a lot of the answers are around us sometimes. But what's your takeaway on this? It's a lot to unpack.
Yeah, I mean, it makes sense to learn from every source of learning you can get. And so in the natural world, I mean, the natural world has had a little bit of a head start over our species
Just a
specifically. We're
just a little
part of
bit.
it, but we're discovering a little bit more every day, which is part of what's exciting is I think AI is going to help us find more of these discoveries. So, what you mentioned about the co-location of memory and processing and the bottleneck and the energy and efficiency, that's a big, big part of the problem. There's a lot we can learn from the brain. And in fact, actually, as another call out to Digital Now 2025, one of the keynotes I'm excited about this year is a talk by a medical doctor and an AI expert teaming up to talk about the similarities and the differences between the way the human brain and the way AI brains work. So you got to check that out. That's going to be an amazing session. Um, I'm sure we get into a lot of these concepts. So, my general viewpoint is that there's a lot of opportunity. We are insanely inefficient in the way we do AI. Part of it is what you're describing at the compute level, where you have compute and memory separated essentially by the Grand Canyon or by the Pacific Ocean is probably a better analog in terms of distance to cover. So it's very 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 difficult to address that with the classical computing architecture we have. Lots of people are working on lots of different innovations. That's actually part of what makes the Grok language processing unit and the Cerebrus wafer scale technology so compelling, is because they're able to reduce that bottleneck dramatically by not co-locating memory in the exact way you're describing with neuromorphic designs, but somewhat similar to that in some ways. They're able to reduce a lot of those memory bottlenecks. And so there's a lot of innovation happening in this area, and that's really, really exciting. So anything we can do to become more efficient, that's better. The other thing that's really, really inefficient about current AI is that we have what's called the quadratic problem in the current transformer architecture, which we've talked about a little bit on this pod in the past. But as a quick refresher, the bigger the context window, meaning the amount of information that's being processed, whether it's text tokens or pixels or segments of video, um, essentially what's happening right now through the attention mechanism in this transformer architecture is you're comparing every token against every other token in order to predict the next token. And so that mechanism, there's lots and lots of optimizations that have been happening since the original transformer in 2017. But ultimately, we still have some flavor of the quadratic problem, which is really ridiculously inefficient. And so we're solving that with massive amounts of compute, massive amounts of energy. There's going to be algorithmic progress. There already has been a lot of algorithmic progress that is advancing the field in a way that's going to make it more and more efficient. Part of what made DeepSeek back in January such a big deal is that they were able to do, at the time, O1 and then almost O3 level processing performance with radically less training and in a more efficient way. And the same thing was true for the Kimi K2 model that came out about a month and a half ago. It had GPT 4.1 level coding ability with far less requirements. So we are innovating really fast, and that's exciting. I think coming back to the topic for today in terms of hardware, the more general concept of neuromorphic designs or designs essentially that mimic, the biology, in this case, the neurobiology of the brain, are super interesting. And the one hot dog versus a quarter million hot dogs, yeah, it's kind of what it is. We've got a pretty efficient power plant, running for us in terms of powering our brain, and our brains can do some pretty amazing things.
And as a note too, the hot dog reference I got from Mark Hersum's TED Talk that I mentioned, and I believe he did the TED Talk in Chicago, so he was talking about Wrigley Stadium. You know what else is in Chicago is Digital Now, so maybe we'll have to do some hot dog analogies there.
For sure.
Meath, what do you think about? I guess where I'm stuck here, I will say in the past 2 years, I know we've talked about infrastructure and energy demands. I think even for me, more recently, I'm starting to understand how serious this is. Like we've talked about it kind of abstract, but the past probably 6 months to a year, I've realized, wow, this is truly a bottleneck and something will have to change. What would you say to people that, I don't know if feel bad is the right phrase, but feel like they should wait before implementing AI organizationally or for their members until we have a more efficient way to use it?
The question is what's the threshold that you need to be at in order
Mm.
to consider it reasonable enough, and how does it compare to your existing energy use in other aspects of your life? When we talk about, for example, the use of Google, every single Google search pretty much comes back with a AI search result at this point. So, and Google is by far the biggest inference provider in the world through Google search, because they're running, I think, like 10x as much inference as anybody else in the world, including OpenAI, because they run Google search on top of this AI layer. And that was done because, quite frankly, the demand is speaking for itself. Most people are going to AI to look things up than they are going to classical Google search. So Google had to change their game. And so you are basically using AI already. Now, how heavy do you go into it? How big do you go into it? Are you concerned about the energy consumption, the water consumption? I am. Yet I also feel that, first of all, disadvantaging yourself, first of all, like if you're doing good work to advance some cause in your field, and if you're disadvantaging yourself in your field because you're not using AI, that's not good. The other thing is, the way we're going to solve a lot of our scientific problems, and climate is a branch of science that needs as much energy as we can put towards it, is through AI. And that's really the chance that we have to resolve this. So I think that it's a double-edged sword, no doubt. Most new technologies are. This one is one that I think has this potential of giving us new solutions. I also think that the additional demand is going to force us to be a lot smarter about the way we think about regulation around energy. Thinking about nuclear, you mentioned that earlier. That AI companies are not just thinking about it. I think they're pretty far along in bringing back decommissioned nuclear plants as well as building new ones, and then getting into alternate forms of more modern nuclear technology like SMRs, which stand for small modular reactors, which are essentially like 18-wheeler sized containers that can power 1,000 homes. And these things are designed with modern physics and modern understanding of material science, and are done in a way where they're kind of inherently safe or dramatically safer than any other preceding nuclear technology, both because of the physics in terms of how they cool. They have passive cooling essentially, which doesn't require generators to pump water through them. That's part of it. And the other part of it is the materials that are used, while still radioactive, are not capable of being reprocessed into weapons grade material. So you solve two of the biggest issues with nuclear technology with the more modern approach. But the United States specifically has been pretty backwards about our mindset about nuclear for some time. And of course, that's my opinion. But the reason I say that is, many other countries, including some very climate oriented countries like France and others in Europe, have gone big on nuclear in some with classical nuclear technology and some with some of the newer technologies I'm describing. So I think and nuclear, the reason it's such a big conversation is because it is not carbon emitting. It's basically something that has much more of the profile that you'd want in order to be climate oriented and environmentally sensitive. So if we can solve some of the bigger nuclear questions, and that's not even talking about fusion, right? Fusion would be the one if we can figure that out for any kind of fixed generation requirement. Pretty much solve energy if you can solve fusion, and that's on the radar. But I don't think there's anything around the corner in terms of commercialization of that. But with SMRs and other forms of advanced nuclear technology over the next 5, 10 years, we can definitely solve a big part of this problem if we're willing to do that.
So, do you think it's safe to say, based on what I referenced from Sam Altman earlier, that we have way more advanced AI out there, but it's just not released to the public because we can't support it with the energy demands?
First of all, I think there's a chance that he's got more advanced AI. I also think there's a chance he doesn't. I don't
Ah,
know that I
okay.
mean, I suspect he probably does. But both because of alignment and safety, and also because of the practicality of deploying what's presumably larger models and even more compute intense models, there are some constraints that aren't about, um, the most immediate demand. I also think that in the world we live in today, with the competition very, very strong from lots of major players, not just the ones that are heavily funded to the tunes of tens of billions of dollars, but these startups in China that are doing unbelievable work. There's lots of people out there that are releasing great models, and so OpenAI has to have kind of the next thing out there. But my bottom line on it, coming back to energy, is I think there's the energy constraint. I also think there's the manufacturing supply chain constraints that are equally problematic, because there's just not enough compute capacity. And to have the compute online, you have to have construction. To have construction, you have to have cement. You have to have a lot of labor. You have to have an environment where you can bring in materials from anywhere in the world in a cost efficient way, and on and on and on. Of course, energy powers all of that, but I think there's a lot of complexity to this, to just say, hey, we want to support 2 billion people on ChatGPT. It's going to take a lot of work from a lot of different industries.
Hmm. Do you think AI will solve its own supply chain issues and energy problems?
I think AI plus a lot of human
Okay.
labor will
Well,
solve a lot of
right.
these problems. But I think AI is going to be a big part of it, because the scale of these problems is, I think, it's not necessarily beyond any of our capacities. It's just the number of genius level people that are out there who can solve
Mhm.
these novel problems is very limited. And there's more of them today than there were 100 years ago, because our population is larger and education is more broadly available. And, people have healthier lifespans. So really smart people who do this kind of crazy work in physics and stuff like that, they live longer so they can contribute more. All those are exciting things. But those are all linear scale solutions to what is an exponential problem. It takes us 25 plus years to grow a human from zero to the point where they're, kind of useful in the workforce, right? And contributing. And that's a long lead time. That's a really long lead time. That's 50 doublings in AI power if we stay on the same pace that we're on now, which is basically inconceivable in terms of how big of a number that is. both in terms of power, but also in terms of what the requirements are to fuel it. So, I think that AI coming online strong, where we have the equivalent of hundreds of billions of PhD level people working on this problem, yeah, you're going to solve a lot of issues that we cannot solve as a society. We just don't have enough kind of intellectual horsepower available to solve these problems.
One takeaway, Amith, from this episode, I know we covered a few things, rapid fire, and then we talked about the nanotech, which is quite interesting. What do you think's the takeaway here?
To me, the thing that you have to remember is there's always a kind of order of magnitude shift waiting around the corner. So, this idea of neuromorphic computing in general, and then specifically the neurobiology of the brain and the structure, we're only talking about one aspect of it that this particular design is trying to solve for, which, by the way, this is far from commercialization. It's in the lab right now in an academic environment, but we're moving things through those pipelines faster. But if that were to happen, you have like 100x improvement in efficiency, which also likely means approximately the same improvement in compute power, which is unbelievable. And this is just one particular dimension of the advantages of our biology. It doesn't talk about things like neuroplasticity, which is the ability for our neurons to be able to kind of strengthen, weaken, sever, and regrow new synapses between neurons, which is not something that AI models can do right now. There's lots of algorithmic research happening in terms of there's different approaches to this, but the basic idea of mimicking that in the model, where the model can continue to grow and kind of adjust its weights, which is theoretically very powerful, but also potentially very dangerous, because all the things we do for AI safety and evals are based upon the idea of a model being fixed in time once it's trained. So there's a lot more, and so I would say to people, don't be rooted in the idea of what you can do now. So obviously, you have to start somewhere. So learn what's going on now, because that's how you prime your brain to understand this new world we're entering into. But don't think about what you can and can't do in your business and with your strategy or with your career even, based on what the capabilities are today. Like we started this episode, we've updated Ascend. This is the third edition coming out this fall, and it's radically different than it was even 2 years ago. And we do this stuff for a living, but we could not have predicted what's happening right now 2 years ago. And we say that very openly to people. So the thing you have to do is get really good at recognizing what the worthy but currently unsolvable problems are. What I mean by worthy is that they're important. They're things that if you could solve problem X, it would mean a phase change, a step change in your business, your ability to deliver value, your ability to solve problems in your field or in your profession. And there's a lot of those. There's lots of these so-called unsolvable problems. And those are the ones that I get excited about. So any problem that someone says, we can't solve that, that's not solvable, that defies the laws of physics, is what they'll say, which is generally never true. But these unsolvable problems are super exciting, because with what's happening with AI, actually, they're likely to be solvable and maybe even solved in 18, 24, 36 months. And if your strategic planning horizon is 2 years, 3 years, maybe even longer in some cases, if you're really ambitious, well, you should be thinking really hard about what's going to likely change and plan for the AI that will be here in a year to the greatest extent you can. I don't know if you can do it for 2 years, but say 6 to 12 months from now, there's certain things that I'm pretty sure are going to be in our hands. And you should build your business model around that, not around today's capabilities.
Mm.
That's
The
my
next
takeaway.
exponential leap is just around the corner. And I feel like digitalNow is a great place to go to start looking ahead. I hope you all will join us. We'll have some hot dogs. We'll see how much energy we need to get through those few days. Everybody, thanks for tuning in to today's episode, and we will see you all next week.
Thanks for tuning in to the Sidecar Sync podcast. If you want to dive deeper into anything mentioned in this episode, please check out the links in our show notes. And if you're looking for more in-depth AI education for you, your entire team, or your members, head to sidecar.ai.